The first one we're going to look at is magnesium and hydrochloric acid. So we've got bits of magnesium here, so go ahead and grab one of those please, Jim. We're going to put them into a test tube. Just use one of the smaller ones, I think, Jim.
They're similar in size.
Okay. And then we're going to add, what do you reckon, about a couple of fingers worth of
yeah, just enough
HCl?
to sort of cover the surface.
What's the molarity of the HCl there?
This is a 1.0 molar hydrochloric acid.
Okay.
Just be careful not to spill this. And I have just enough to cover the surface of the magnesium.
Okay. Let's look at this. So when we're doing observations, what we're interested in is what we can see, what we can hear, and what we can feel. Now, when we put our fingers around that, it feels warm, right?
It does. It is getting warmer.
Yeah. A couple of other things you'll notice. You'll see the bubbles there. You see, it's not white. That solution hasn't turned white. Those are just bubbles that are coming off the magnesium. Now, the other thing, you'll have to take my word for this though, is that the magnesium is actually dissolving. It's actually turning into magnesium ions. So if we let this sit for long enough, which we're not going to do here, we would actually see that entire piece of magnesium disappear at some point. And then the bubbling obviously would cease at the same time as well. And when I'm talking about what we hear, if you listen very closely, you'll hear some fizzing as well. And that's just really the bubbles coming off the surface of the magnesium. This next reaction is the zinc, and there's a 1 molar copper sulfate that we're using here.
Yes, it's the dark blue, and it's 1 molar copper.
Yeah, could you bring it up to and we'll bring that up to the camera there. So that one, just move it over a little bit. That one's 1 molar. You see it's a dark blue. Then the other one that you might have access to, go ahead and let's bring the other one up, is this lighter one. That's still copper sulfate as well, but that's 0.1 molar. It's an obvious difference between them. One is used. One's much darker than the other, so you'll make sure you use the correct one, but we need to use the 1 molar here for the zinc. So we're getting a test tube here. We've got some zinc. The zinc is just a piece of metal here. There we go. Oh, would you put that, sorry, move it over a little bit, Jim, so we can see it, yeah, and then stick it in.
You may need to bend the zinc, make it fit inside the test tube.
Oh, it's possible, yeah. So let's just show them what it looks like inside the test tube there. Move it up a little bit, please. No, sorry, move it towards the camera. Yeah, and you can see now it's in there, and now he's going to add the copper sulfate. Okay, make sure it's in the camera, Jim. There we go. Perfect. A little bit over. There we go. Perfect. So that's the zinc in the bottom. We're adding the copper sulfate here. All right. Now a couple of things you can observe here. Give it a little bit of a swirl there, please, Jim.
I see dark.
Yeah, let's put it in the camera here, and you can see. Let me. Yeah, right. Now take a look. What do you see, Jim?
I see the surface of the zinc is turned like a dark color.
Right. So it's almost a brownish color, isn't it?
It is brownish, but it is hard to tell because the interference with the blue color from the copper sulfate solution.
Now, speaking of the copper sulfate solution, what do you notice about that?
Its color is becoming slightly less blue over time.
Yeah. Yeah. If you compare that, let's bring the other one up and compare it. You can see it's almost like a greenish color now when you compare it. So you can see something's happened to the liquid too. The liquid's changed its color a bit as well. Do you see any bubbling, Jim?
No, nothing obvious.
No. Okay, no bubbling. Now the other thing that's important here. Put your hand around it. Let's see if there's any heat.
Nothing obvious either.
Yeah, nothing obvious here. No, we don't hear anything because there's no fizzing.
No.
So it looks like that's pretty much it. Let's put this back in the camera here, and we'll just you can just see.
I've noticed also if I shake it a little bit, some of that brown material, which now is definitely brown, is flaking off the surface of the zinc.
Yeah, it's almost like it's copper colored.
I believe so. Looks like a penny.
Yeah, it's interesting. All right, put it back.
There we
in
go. If
thing.
you look at it on the surface of on the glass of the test tube, you can see some of the material.
Right, excellent. Alright, so this one requires 0.1 molar CuSO4. We talked about this in the previous one. Notice how it's lighter than the other one. You can see the other one in the background. It's that dark blue color. But we're interested in this light one, so we're going to have a CuSO4, 0.1 molar. We're going to put that in, and then we're going to add HCl to it. So you'll notice the initial color of this copper sulfate is very light blue, almost a greenish color, so like a cyan. Would you put that in the shot, please? All right, you can see it there. All right, go ahead and add the HCl. We'll see what happens. And I'm looking at it, and I don't know, it just looks pretty much the same to me.
Nothing obvious.
Yeah. Any gas formation?
No bubbles.
No bubbles, so you're not going to hear anything. And when you feel it, do you feel anything?
No,
okay, let's put it back down in the shot here. Yeah, you see, it looks pretty much the same as what it was when we started. I think that's why it's important that we use the 0.1 molar. If you use the 1 molar, I think you might see a color change. It's possible, but I still don't feel like there's really anything happening at all. So we're using the 0.1 molar copper sulfate again. That's the lighter one, lighter bluish one, and then we're going to use the sodium bicarbonate. So let's add the first one, the copper sulfate. Okay, it's good. Now let's add the sodium bicarbonate. It's NaHCO3, right?
Yes, NaHCl3.
Okay, let's take a look at that in the camera. Alright, what do you see, Jim?
I see some white particulates.
Okay, and do you see any
Forming.
bubbling? You know,
not obvious.
Not obvious. Now, sometimes, you know, it can depend. If your test tube is not very clean, if it's got some sort of acid in it, it's possible you might actually see some bubbling with this one. But if your test tube is completely clean, put it down a shot a little bit, please, Jim. All you'll probably see is what we're seeing here. Now, you'll notice, look at a little bit lower. Look at the very top, and you'll see that it looks like the solution has changed color as well. It's almost like the solution has become almost colorless, wouldn't you say, Jim?
I agree, yes.
Yeah, and if you look at we do have a particulates in there. It's definitely some solid coming out of this. Can you look at the heat? See if we can.
No, it's not changing temperature.
No, not changing temperature. So there's no heat changes. There's no fizzing, so we're not hearing anything. So I think that's all we're going to see with this one. So this one is the copper sulfate, 0.1 molar, again the lighter one, and ammonium hydroxide. So go ahead, Jim, and let's put the copper sulfate in. So that same light bluish green liquid, and now we're going to add the ammonium hydroxide. Okay, let's bring it close to the camera here. We'll see what's going on. A little bit lower, please, and a little bit higher. There we go. Give it a little bit of a swirl. All right, so I'm looking at it. It looks like there's definitely a precipitate there, wouldn't you say?
Yes, there's a definite precipitate.
And also, when looking at that solution, I'd say if you certainly look at the top of the solution, it seems to have become almost colorless. So I'd say that what's causing the blue color there is more the precipitate than the solution. So I definitely think the solution has changed color as well. Doesn't seem to be any changes to heat, right?
No.
And I don't see any bubbling. I don't hear any bubbling either. This one is the magnesium and the copper sulfate. So we've got the magnesium there, and we're going to stick that in. And now we're going to add copper sulfate. So it's a 0.1 mole of a lighter one that we're using.
Yes.
Alright, that was good. That'll be fine. Alright, as you can see these little brown particulates coming off there, and you can see them, they're forming also on the metal surface itself. Take it down just a little bit, please. There we go. I'm going to zoom in on that. Let's move it just up a little bit, please, Jim. Alright, you can see those particulates. Look at the color of the solution as well. I also see some bubbling too that's occurring here. Sometimes you'll see the bubbling, sometimes you won't, but I'm definitely seeing it here. Could you put your hand around it, Jim, see if there's any changes in heat?
It's not obvious.
No, not obvious, okay. Yeah, so we see the particulates and we look at the solution. Solution definitely looks lighter than what it was as well. Could you? Yeah, so I think that's pretty much all we're going to see with that one. Alright, so we've got the HCl here and the sodium bicarbonate. Which one are you going to put in first, Jim?
I'm going to put it in the HCl.
Okay, so it's going to put the HCl in. The HCl is just a clear, colourless liquid. Doesn't look any different from water, really. Okay, so he's put about 2 fingers worth in there, and now he's going to add...
This is the sodium bicarbonate.
Yeah. So yeah, make sure it's sodium bicarbonate, not sodium carbonate. Okay, let's bring that a bit closer to the camera here. Give it a bit of a swirl. Yeah, what do you see there, Jim?
I see lots of bubbles.
Yeah, let's put it down a little bit. See any precipitate?
I do not know.
No precipitate? Okay. Put your finger around it. Any changes in heat?
Not obvious.
Yeah, not obvious. Okay. Yeah, and the solution looks like it's just remained colourless as well, doesn't it?
It did, yes.
Yeah. Alright, that's it. So we're doing ammonium chloride now in water. So the ammonium chloride here is a solid, and Jim's going to go ahead and put a little bit of that into a test tube. It's kind of a smelly solid, isn't it?
Yeah, keep your nose away from it.
Yeah. So he's going to put it maybe, what, a couple of scoops?
Yeah, enough so I can see clearly at the bottom.
Yeah, that's good. We're going to add some water to it as well, and we'll see what happens. Could you put it in the camera, please, Jim, when we're doing this? That's good. And he's going to give it a bit of a swirl around. Now you'll notice that the solid is disappearing. And what do you notice when you put your fingers around it?
It is getting colder.
It's getting colder, okay. Alright, let me say a little bit about this, because you know, you can see that the solid has disappeared and it has gotten colder. Now this doesn't necessarily mean that it is a chemical change, because what can happen is that things can get colder and just dissolve without really being a chemical change. Because I know with ammonium chloride what happens is that I could actually take that solution, evaporate it, I can get the ammonium chloride back, which makes this more a physical change than a chemical change. So the fact that it cooled down really doesn't indicate anything chemically was going on. There were no changes in colour of the solution, looks the same.
No.
There was no precipitate, no bubbling, nothing else to indicate that there was a chemical change going on here.